Okay, the last section of chapter 7, part 1, we're going to multiply polynomials. We multiplied binomials last time, and binomials are actually polynomials, but we could do polynomials of different sizes. Okay, so for example, when we're going to do binomial squares, which is actually just multiplying binomials, but because of the way it's set up, it makes you think it's a different type of problem. So because it says 5x plus 4 to the second power, this is really saying 5x plus 4 times 5x plus 4. So when you see that, just write it out 2 times. Then we can multiply it out just like we were multiplying it out last class. I'll go ahead and distribute the 5x. So 5x times 5x is 25x to the second. 5x times 20 plus 20x. And then I'll go ahead and distribute the 4 times 5 and the 4 times this. 4 times 5x, 20x. 4 times 4 is 16. And then just like last class, I just combined the like terms. So the 25x squared is fine. I have a positive 20x plus 20x, so that's going to add up to 40x's and plus 16. And then just remember when you're doing these, you can't distribute the squared. You have to actually multiply it out, and you end up with 4 terms, and then you combine the like terms. Okay, so for B, it's what we call a binomial square again, but x minus 7 to the second is just a lazy way of saying x minus 7 times x minus 7. And then once I write it out, I can multiply the binomials just like we did last time. First, I'll distribute the x to the second binomial. So x to the second minus 7x. And then I'll distribute the minus 7. So minus 7x. Minus 7 times minus 7 will be positive 49. I'm going to bring down the x to the second. Minus 7 is going to be minus, and then I'm adding it up to 14x. If I have 2 minuses, I get an even bigger minus as my total. Okay, so my final answer is x to the second minus 14x plus 49. And I should have had 4 terms because I was doing a binomial times a binomial. Okay, now the example 2 is going to be difference of squares, which I'm just going to multiply 2 binomials together. It's just to show you what normally happens when you multiply them. So this is called a difference of squares based on the answer, but it always looks like this. This is x plus 6, this is x minus 6. The 2 binomials look exactly the same, except one has a positive and one has a negative. Okay, but the way I do it is just like all the other ones. So x times x times the minus 6. X to the second minus 6x. Then I'll distribute the positive 6, so positive 6x. Positive 6 times negative 6 is negative 6 times 6, 36. Okay, I'm going to bring down the x to the second. Okay, now I have minus 6x and positive 6x, so I subtract. 6 minus 6 is nothing. So these actually cancel out. And so I'll just bring down the minus 36. So this is called a difference of squares because this is x squared minus 6 squared or something like that. Okay, it is possible for these to cancel out, but they will only cancel out if it's set up like this, where it's the exact same thing, but 1 plus 1 minus. If they have the same sign, they will never cancel out. So if you get them to cancel out and it doesn't have this pattern, then you've made a mistake and you're going to go back and check your mistake. Okay, so for B, it's a difference of squares. It's 2x minus 5 and 2x plus 5. Because it's set up like that, I'm guessing they're going to cancel out, but I'm going to multiply it out to make sure. So 2x times 2x is 4x to the second. 2x times 5 is positive 10x. Minus 5 times 2, minus 10x. Minus 5 times 5 is minus 25. Okay, I'm going to bring out the 4x to the second. Let me check my like terms. I have 10x minus 10x. 10 minus 10 is nothing, so these do cancel out because one's positive and one's negative. And then I'll bring down the minus 25. Okay, and remember, those only cancel if it's set up where each binomial is the same with opposite signs. Other than that, they should not be canceling. Okay, the last example. Instead of multiplying a binomial by a binomial, we're going to multiply a binomial by a trinomial. It's the exact same process, and it wouldn't even have to be a trinomial. I could add like 6 terms here, and you would still be able to do it. The way I do it is exactly the same. I take the x, and I'm going to distribute it, except for I have to distribute it to 1, 2, 3 things instead of 2 things. So x times x to the second is actually x to the third, because this is like a 1 plus 2. Okay, x times 7x is 7. X times x is x to the second. X times 5 is 5x. So since I multiplied it out to 3 things, I end up with 3 terms. Now I'm going to take the next thing, the 3, and distribute that to all 3 things. So 3 times x to the second is 3x to the second. 3 times 7x is positive 21x. 3 times 5 is 15. Okay, and I did get 6 terms, and that's because I did a binomial by a trinomial. I did 2 things times 3 things. So I ended up with 6 things. If you don't end up with 6 things, then you think, oh, I must have missed one, and I'll double check. Okay, so I'm going to go in order to put it in standard form. So I see x to the third, but I don't see any other like terms. Okay, now let me check the x to the second. So I have 7x to the second plus 3x to the second. So I have 10x to the seconds. Okay, let me check the x's. I have 5x plus 21x, so 26x. And then what did I leave off? I left off that plus 15 at the end, which is called the constant term. Okay, this is my final answer. It is in standard form, and there's no like terms left. So this is a good answer. Okay, so for B, I'm going to do the same. Just make sure you distribute to all 3 terms. Feel free to pause the video if you want to try it first and then check. Okay, let me start with the 2x. So 2x times x to the second. 2x to the third. 2x minus 3. Minus 2 times 3 is 6. X times x is x to the second. 2x times 4 plus 8x. So I distributed it to all 3 terms. Now I'm going to distribute the plus 5 to all 3 terms. So plus 5x squared, 5 times negative 3, negative 15x, 5 times 4 plus 20. I have 6 terms because I did a 2 term by a 3 term. Okay, are there any other x to the thirds? No. 2x to the third, negative 6x to the second plus 5x. So negative 1 x to the second, or you can just write x, negative x to the second. Okay, I have 8x minus 15, so that's going to be negative, and then when I subtract, I get negative 7x. And then what I left off that, and there's my 20 at the end. My constant term always goes last. Final answer. Okay, for C, x minus 3 times x squared minus 2x plus 5. Same exact process, I just put a minus to make sure we distribute our minus sign. Okay, so x times x to the second, x to the third, x times negative 2x. Negative 2x to the second plus 5x. So I got all 3 terms in the second trinomial. Now I'm going to distribute minus 3, so minus 3x squared. Minus 3 times minus 2x is going to be positive. 3 times 2 is 6, and I'll keep the x. Minus 3 times 5 is minus 15. I have 6 terms, which means I probably got them all. Okay, x to the third. Now let me look for the x squareds. Negative 2x squared minus 3x squared is negative, add them up, 5x squareds. 5x plus 6x is 11x. And then the minus 15 constant term. Constant term, you always go last. Okay, last one. And then I've pretty much given you as many polynomial multiples as I will. Okay, so 3x times this, times this, times this. Okay, I got all 3 terms, so now I'm going to distribute the negative 2. Negative 18x to the second, negative 12x, negative 8. Okay, got 3 more terms, so I have a total of 6 terms, which is a good sign. So my cubed term has no like terms. Let's see, I have 18x squared minus 18x squared. Well, that's nothing, that's zeros. Okay, so those cancel. Let me check the x's. I have 12x minus 12x. 12 minus 12 is also nothing, so that cancels. So what am I left with? I still have the minus 8. So this one happened to have the terms cancel, and so it has the nice answer 27x to the third minus 8. That doesn't normally happen, but it is possible, so I want you to see that it is possible. Okay, so that's the end of Chapter 7, Part 1.